Okay, this is a continuation of the first video. Apparently we ran out of room, so picking up where we left off, this was question G, where we were answering the question, which quadrants contain which values? Describe an integer game scenario represented in each quadrant. So, as we were saying, quadrant 1 and 3 are all positive values. So that means picking up a positive card or discarding a negative increases the score. And then quadrants 2 and 4 are all negative values. And basically that represents picking up a negative value or discarding a positive value is going to decrease our score. All right, let's go ahead and go to the next page. All right, so our example 2 is using properties of arithmetic to explain multiplication of negative numbers. So we're actually going to do this part together because I want to step through it. This can get a little confusing, so I want to take this part slow. So the first question I have for you is we have used the integer game to explain that adding a number multiple times has the same effect as removing the opposite value of the same number of times. So what is minus 1 times minus 1? So if I take away a card with a value of negative 1, then I'm increasing my score by how much? 1. All right? And if I add a card with a value of positive 1, then I'm also going to get 1. Okay, so what we're looking at is we've already talked about and we've proven that if I take away a card with a value of negative 1, I'm going to increase my score by 1 because it's a reflection of 1 times 1. So removing a negative 1 card is the same as adding a positive 1 card. All right, so my second question is, why are 1 and negative 1 called additive inverse? So what property represents the additive inverse? Well, the answer to that is because negative 1 plus 1 is equal to 0. All right, so that's going to come in handy, or we could say 1 plus a negative 1. It doesn't matter. But these two things that we've talked about and discussed are going to come in handy to where we prove that negative 1 times negative 1 is positive 1. All right, so we're going to show you why this is true using the properties of math. All right, so we know that minus 1 plus a positive 1, or 1 plus a negative 1, is 0. And we're going to show that negative 1 times negative 1 is the additive inverse of negative 1, which is 1. All right, so let's go ahead and start this. If negative 1 times 0 is equal to 0, right? Well, what property is that? That's the 0 property. Because any number times 0 is going to equal 0. Everybody agrees with that. Okay, now we're going to take a look at each term and see if we can represent this by another expression. Well, if that's the case, then negative 1 times, and we're going to replace 0 with this statement right here. 0 is equal to negative 1 plus 1. And we're going to put that in brackets. So I'm just going to, if 0 is equal to this, we're going to use this in place of 0. And I'm going to turn it around here. So this is 1 plus a negative 1. So I've replaced the 0 with this expression because we've already said that 0 can be equal to this. And that is also equal to 0. So we have substituted. One plus a negative 1 for 0. All right, So that's all we did here. Took out the 0, replaced it with 1 plus a negative 1. Now we're going to use distributive property. If I multiply something on the outside by something in the inside here, then I can distribute this. I can multiply negative 1 times 1. So I'm going to write this here. Negative 1 times a positive 1. And then I can add it to negative 1 times negative 1. Negative 1 times negative 1. I'm going to put that in parentheses, and that is going to be equal to 0. So what did we just do here? This is called the distributive property. All right, so we have the distributive property. Well, what is negative 1 times a positive 1? If I have one copy of negative 1, I know that that is going to simplify to negative 1. Now, I'm going to skip this part here because whatever I come up with here is got to equal to 0. And I'm adding. So what can I add to negative 1 that is going to equal to 0? Well, the answer has to be a positive 1. Well, if that's the case, then this right here has to equal positive 1. Because in order to have the additive inverse, or to show the additive inverse, I have to have negative 1 plus a positive 1 to equal 0. So if that's the case, then that means negative 1. All right, let's finish this up. So therefore, negative 1 times negative 1 is equal to a positive 1. All right? Because again, right here, this is the key. If I have negative 1 plus some number equals 0, well then that number has to be a positive 1. Therefore, negative 1 times negative 1 has to be a positive 1. All right, so since negative 1 and the quantity of negative 1 times negative 1 have a sum of 0, they are the additive inverse of each other. So that's what we'll put here, additive inverse. That means we can conclude that negative 1 times negative 1 is 0. And we can also use that to show that negative 1 times any number, we'll call it a, is going to be equal to the opposite of a for any integer. And that, and also, negative a times a positive b is equal to the opposite of multiplying a times b. Okay? And that's for any integer. So if I take the opposite of a and multiply it by b, it's the same thing as multiplying a by b and taking the opposite of it. All right, so that concludes that demonstration of how we can use the properties to prove that a negative times a negative is a positive. All right, the last part is your exercise 1. You are going to multiply integers in the real world. So generate some real world situations that can be modeled by each of the following multiplication problems. Use the integer game as a resource. So you can use integer game for any one of these, but for the first one, what you're going to do is answer the question, minus 3 times 5. What scenario can you come up with that would represent minus 3 times 5? Go ahead and do that and then continue the video. All right, again, there are many possible ways to answer this, but you could say, I lost 3 $5 bills, now I have minus $15. So that could be one way to show it. You can come up with a different way. All right, the next one is -6 times -3. So again, sometimes that's a little bit harder to show in real life, so maybe come up with an example from the integer game. How can that be represented by the integer game? And you can say, I discarded 6 cards with a value of -3 each. That means my score will increase by 18 points. And the last one, 4 times a -7. Again, you can use integer game. You can use, if you can think of something right away that this would fit with, you can come up with something like this. The temperature dropped 7 degrees in each of the 4 hours being recorded. By the end, it was 28 degrees colder. Notice how I don't have minus 28 here, but because in the context of the problem, the colder represents the negative or the decreasing of temperature. All right, go ahead and bring this to class and we'll work on it and do some practice problems.